Steel. Fire. A skyline that had stood for decades suddenly glowed orange against the night. Sirens echoed across Kiev as another wave of missiles cut through the darkness. Windows shattered. Shockwaves rolled across empty streets. In the distance, workers stood frozen, watching flames climb higher and higher into one enormous aircraft hangar. No one spoke. They already knew what was inside. For a brief moment, the world's largest airplane, the machine that had carried impossibly heavy cargo across continents, survived the collapse of an empire and become a symbol of engineering without limits, was fighting its final battle without ever leaving the ground. Then the roof collapsed. A cloud of smoke swallowed everything. Around the world, aviation enthusiasts refreshed their news feeds in disbelief. Pilots who had flown alongside the giant refused to believe the first reports. Engineers who had spent decades maintaining the aircraft stared silently at photographs that looked almost unreal. The impossible had happened. But even as the fire continued to burn, another question emerged. How could a single airplane become so important that its destruction felt like the end of an era? Because this wasn't just another cargo aircraft. It was the Antonov An-225 Mriya. A flying machine so enormous that many people believed it could never have existed in the first place. Yet its story didn't begin with cargo. It didn't even begin with aviation. It began with fear. The fear of losing the Cold War. But this machine was never supposed to exist. Everything started decades earlier. The year was 1976. The Cold War had entered one of its most intense technological races. The United States and the Soviet Union weren't simply competing for military superiority anymore. They were competing to prove which political system could accomplish the impossible. Every rocket launch carried political meaning. Every satellite became propaganda. Every scientific breakthrough was another message sent across the Iron Curtain. And above all of them stood one objective: space. The Soviet Union had stunned the world with Sputnik. It had sent Yuri Gagarin into orbit before any American astronaut. But by the mid-1970s, momentum had shifted. The United States was advancing rapidly, while Soviet planners searched desperately for a project that could restore technological dominance. The challenge wasn't just building spacecraft. It was moving them. Thousands of kilometers separated Soviet manufacturing plants from launch facilities in Kazakhstan. Rocket components had become so massive that railways could no longer transport them efficiently. Roads were useless. Rivers didn't reach every destination. Every delay cost millions of rubles and months of precious development time. The Soviet leadership demanded an answer. And they wanted it quickly. But nobody expected the solution to come from an aircraft factory in Ukraine. Northwest of the Black Sea, inside the city of Kiev, stood one of the Soviet Union's greatest engineering organizations, Antonov Design Bureau. Its reputation had been earned through decades of building rugged transport aircraft capable of operating almost anywhere. Frozen Arctic airfields, desert runways, mountain valleys. If cargo needed to reach an impossible destination, Antonov usually found a way. Leading the bureau was an engineering culture shaped by one remarkable man, Oleg Antonov. Although Antonov himself was approaching the end of his career, his philosophy still guided every project inside the company. Simplicity where possible. Strength where necessary. Practical engineering above political spectacle. His successors inherited those principles, but they also inherited an impossible assignment. Design an airplane larger than anything humanity had ever flown. Not slightly larger. Not marginally stronger. Completely unprecedented. Many engineers believed the request bordered on fantasy. The aircraft would need to carry loads heavier than entire passenger jets. It would have to transport gigantic rocket boosters and the Soviet space shuttle, known as Buran, across thousands of kilometers. It couldn't simply lift them. It had to do so reliably, repeatedly, and safely. There were no existing blueprints. No previous aircraft to copy. No engineering handbook explaining how to build something this enormous. Every calculation pushed beyond established limits. Every design needing raised new problems. And every delay increased pressure from Moscow. Because somewhere inside the Kremlin, officials believed failure wasn't an option. History almost forgot how desperate those meetings became. The Soviet space program faced logistical nightmares that threatened its future. Engineers often waited weeks for critical components trapped by transportation bottlenecks. Massive fuel tanks couldn't fit conventional routes. Rocket stages demanded extraordinary handling. Without a revolutionary transport system, one of the Soviet Union's greatest strategic ambitions risked falling behind. Then someone proposed an idea so ambitious that even experienced designers paused before speaking. Why not build an airplane capable of carrying an entire spacecraft on its back? The room reportedly fell silent. At first glance, the concept seemed absurd. External cargo created enormous aerodynamic drag. Airflow around the fuselage would become unpredictable. Stability problems multiplied. Fuel consumption would rise dramatically. Even the aircraft's tail would need to be redesigned to avoid turbulent airflow from the shuttle riding above it. Every solution created two new problems. Still, the proposal refused to disappear. Because no alternative offered the same flexibility. The Soviet leadership approved further development. From that moment forward, Antonov's engineers weren't merely designing another transport aircraft. They were attempting to rewrite the laws of practical aviation. Yet this wasn't the biggest problem. Building a giant aircraft was difficult. Building one that could actually leave the ground was another challenge entirely. The numbers grew almost unbelievable. A wingspan wider than many football fields. Landing gear with dozens of wheels to spread unimaginable weight across airport runways. 6 gigantic turbofan engines producing a level of thrust previously associated with multiple aircraft working together. Every kilogram mattered. Every bolt carried consequences. Even the slightest structural weakness could become catastrophic under maximum load. Computers of the era struggled with calculations that modern engineering software performs in seconds. Much of the analysis still relied on experienced specialists checking results repeatedly by hand. Mistakes weren't measured in centimeters. They were measured in disasters waiting to happen. Meanwhile, political expectations continued climbing. The Soviet Union wasn't funding this aircraft merely to solve transportation problems. It wanted another symbol. Another machine capable of astonishing the world. Another reminder that Soviet engineering could still achieve what others considered impossible. But deep inside Antonov's workshops, the engineers understood something their political leaders often ignored. Nature doesn't negotiate. Gravity doesn't care about ideology. Either the airplane would fly, or it wouldn't. And before the first piece of metal was even cut, an unexpected engineering discovery threatened to force the entire project back to the drawing board. That revelation would change almost every major decision that followed. The first warning arrived not from politicians, but from the engineers themselves. Their calculations revealed a problem so serious that it threatened to end the entire project before construction had even begun. The aircraft wasn't simply too large. It was becoming too heavy. Every new structural reinforcement added more weight. Every extra kilogram demanded more lift. More lift required larger wings. Larger wings required stronger supports. Stronger supports added even more weight. The project had entered a dangerous engineering spiral with no obvious escape. Inside Antonov's design offices, long tables disappeared beneath blueprints covered with handwritten calculations. Teams worked late into the night, checking and rechecking every measurement. A single mistake hidden inside thousands of numbers could bring disaster years later. Unlike ordinary aircraft, there was no previous design large enough to use as a starting point. Almost every solution had to be invented from scratch. Fortunately, the engineers already had one powerful advantage. A remarkable transport aircraft known as the An-124 Ruslin. The Ruslin was already among the largest cargo airplanes ever built and had proven itself capable of carrying extraordinary loads across vast distances. Instead of beginning with a completely blank sheet of paper, Antonov's engineers chose to evolve the Ruslin into something far greater. But evolution quickly became transformation. The wings had to grow. The fuselage had to become longer. The landing gear needed additional wheels. The internal structure required massive reinforcement. Even the tail would have to be redesigned completely. Almost nothing remained untouched. Yet this wasn't the biggest surprise. The greatest engineering challenge wasn't inside the airplane. It would sit on top of it. The Soviet space shuttle Buran measured nearly 36 meters long and weighed tens of tons even before additional transport equipment was attached. Placing such an enormous object on the aircraft's back would completely disrupt airflow. Engineers feared violent turbulence could make the airplane uncontrollable at high speeds. Wind tunnel testing became relentless. Scale models spent countless hours inside powerful streams of air while researchers carefully observed every swirl and pressure change. Smoke traced invisible currents flowing across the miniature aircraft. Again and again, unstable airflow formed behind the shuttle position. The original tail simply couldn't cope. That's when everything changed. Someone proposed replacing the traditional single vertical stabilizer with two enormous fins mounted at the ends of a horizontal tailplane. The unusual twin-tail design looked almost futuristic. More importantly, it redirected clean airflow around the external cargo, restoring stability during flight. It became one of the aircraft's most recognizable features. But solving one problem only exposed another. History almost forgot what happened next. As construction planning advanced, engineers realized no existing manufacturing equipment inside the Kiev factory was designed for an airplane of this size. Some assembly tools had to be redesigned before work on the aircraft itself could even begin. Large sections of the fuselage occupied entire factory halls. Newly built components seemed less like aircraft parts and more like pieces of a ship. Visitors entering the assembly building often stopped walking. The unfinished fuselage stretched so far across the floor that workers driving small vehicles looked tiny beside it. Massive wing sections towered overhead, while cranes moved carefully through the factory like mechanical giants. For many workers, this was more than another government assignment. It became the defining project of their careers. Thousands of specialists contributed to the aircraft. Structural engineers, metallurgists, engine experts, hydraulic designers, electrical technicians, quality inspectors. Every bolt tightened by one worker depended upon calculations performed months earlier by someone else. The machine represented decades of Soviet aerospace experience concentrated into a single aircraft. Then came another impossible question. How do you build landing gear capable of supporting an airplane heavier than any ever constructed? Conventional designs simply weren't enough. Antonov engineers created an extraordinary landing gear system with 32 wheels distributed across multiple bogies. The design spread the aircraft's immense weight across airport surfaces while allowing surprisingly tight ground maneuvering for such a gigantic machine. Watching the completed landing gear for the first time left many observers speechless. It resembled the undercarriage of several airplanes combined into one. Yet this wasn't the most remarkable feature. The front landing gear could lower itself during loading operations, allowing the aircraft's nose to kneel toward the ground. Combined with an opening nose section and internal ramps, oversized cargo could be loaded far more efficiently than with conventional transport aircraft. Every design choice reflected practical necessity rather than appearance. But practical engineering rarely impressed political leaders. Moscow demanded speed. Deadlines became increasingly aggressive. Factory managers faced constant pressure to accelerate production without sacrificing quality. Meetings grew tense. Reports traveled directly to senior government officials. Delays required explanations. Explanations invited criticism. No engineer wanted responsibility for slowing one of the Soviet Union's most prestigious aerospace programs. The atmosphere inside the factory became relentless. Shifts extended late into the evening. Lights remained on long after sunset. The sound of riveting echoed across enormous assembly halls while welding sparks illuminated unfinished sections of the aircraft. Every completed component brought the project closer to reality. Yet every new stage introduced another unknown. The real surprise came months later. Attention shifted toward the engines. Rather than developing an entirely new power plant, Antonov selected 6 Progress D-18T high-bypass turbofan engines, each already proven on the An-125. Individually, they were exceptionally powerful. Together, they generated an astonishing amount of thrust, enough to lift a machine weighing hundreds of tons into the sky. Even so, engineers worried. Could 6 engines truly overcome the enormous aerodynamic penalties created by external shuttle transport? Computer simulations suggested yes. Reality would provide the final answer. As the aircraft slowly took shape, workers finally began calling it by a name that perfectly captured its ambition: Mriya. In Ukrainian, the word means dream. It wasn't chosen because the project seemed impossible. It was chosen because the aircraft represented the dream of achieving what no nation had ever accomplished before. But dreams often carry enormous risks. One hidden structural issue remained unresolved, quietly worrying senior engineers even as the aircraft neared completion. Very few people outside the program knew it existed. And when the prototype finally rolled toward the runway, that unanswered question would determine whether the world's largest airplane became a historic triumph, or the most expensive aviation failure of the Cold War. The morning air was cold as thousands of workers gathered along the edge of the runway. Engineers stood shoulder to shoulder with factory employees who had spent years building the aircraft piece by piece. Some held cameras. Others simply watched in silence. Before them rested a machine so enormous that many people still struggled to believe it could actually fly. The 6 engines slowly came to life. One after another, their deep roar rolled across the airfield. The vibration could be felt through the concrete beneath everyone's feet. Dust swirled behind the wings as the giant began to move. Even the test crew understood they were about to attempt something no one had ever done before. Yet nobody could predict what would happen once the wheels left the ground. History almost forgot how tense those final seconds became. Every instrument inside the cockpit received constant attention. Flight engineers monitored engine temperatures. Fuel specialists watched consumption rates. Pilots exchanged only short, precise words over the intercom. Years of engineering would be judged in a matter of minutes. Then the throttles moved fully forward. The enormous aircraft accelerated down the runway. Slowly at first. Then faster. Faster still. The nose began to rise. For a brief heartbeat, the weight of the world's largest airplane balanced between earth and sky. Then the wheels lifted free. Cheers erupted across the airfield. Some engineers embraced each other. Others simply stared upward in disbelief as the giant climbed steadily into the clouds. Against every expectation, Mriya was flying. But getting airborne was only the beginning. The real challenge came once the aircraft entered its test program. Over the following months, pilots intentionally pushed the airplane closer to its operational limits. High-altitude flights, heavy cargo simulations, emergency procedures, engine-out scenarios, sharp banking tests. Every flight expanded confidence while revealing new details about the aircraft's behavior. Surprisingly, many test pilots described the giant as remarkably stable. Despite its immense size, the controls responded smoothly, and the aircraft handled with greater precision than many observers expected. Its massive wings generated extraordinary lift, allowing the airplane to carry loads that had previously seemed impossible. Yet this wasn't the biggest surprise. The world still didn't know the aircraft existed. Throughout much of its development, information remained tightly controlled. Western intelligence agencies had collected satellite photographs showing unusually large structures inside Antonov's facilities, but analysts struggled to determine exactly what they were seeing. Some believed a new heavy transport aircraft was under construction. Others suspected components for another secret military project. No one outside the Soviet Union had a complete picture. Then everything changed. On November 30th, 1988, the Antonov An-225 made its maiden flight. Less than a month later, aviation experts around the world began realizing that the Soviet Union had quietly built something unlike anything ever seen before. Its dimensions appeared almost unbelievable. Its wings stretched nearly 89 meters across. Its length exceeded 84 meters. The aircraft towered over buildings and dwarfed nearly every airplane parked beside it. Even experienced pilots stopped to stare whenever it appeared on an airfield. But the ultimate demonstration had not yet arrived. The Soviet leadership wanted the world to witness exactly why Mriya had been built. That opportunity came in 1989 at the Paris Air Show. As thousands of spectators filled the airport grounds, conversations suddenly stopped. Eyes turned toward the horizon. A gigantic silhouette approached through the sky. But this wasn't merely a large cargo aircraft. Riding proudly on its back was the Buran space shuttle. The sight was almost surreal. The combined silhouette looked less like an airplane and more like a flying space program. Cameras clicked continuously. Television crews rushed to capture every angle. Aviation journalists searched for words that could adequately describe what they were seeing. There had never been a public aviation display quite like it. For the Soviet Union, the moment carried enormous political significance. Mriya wasn't simply transporting a spacecraft. It was carrying national prestige. Every pass over the runway demonstrated engineering capability. Every photograph became international propaganda during the final years of the Cold War. Yet beneath the applause, reality was beginning to change. The Soviet economy was weakening. Political instability spread across Eastern Europe. Reforms inside Moscow accelerated events that few officials could control. While Mriya represented technological triumph, the nation that created it was approaching its greatest crisis. History almost forgot this extraordinary coincidence. The world's most powerful cargo aircraft reached operational readiness just as the superpower that financed it began falling apart. Then came another impossible decision. In 1991, the Soviet Union collapsed. Overnight, enormous military programs lost funding. Government priorities changed completely. The ambitious Buran space shuttle program was effectively abandoned after only one uncrewed orbital mission. Without Buran, the original purpose behind the An-225 suddenly disappeared. The aircraft had been designed to solve one of the Soviet Union's greatest logistical challenges. Now that challenge no longer existed. Mriya entered storage. Its engines were removed for use on an An-124 aircraft that still had active missions. Dust slowly settled across its wings. Inside enormous hangars, the world's largest airplane waited in silence while governments struggled with political and economic chaos. Many believed its story had ended almost as quickly as it had begun. But nobody expected what happened next. Thousands of kilometers away, the global economy was changing. Industries demanded transportation for cargo too large, too heavy, or too urgent for conventional aircraft. Massive power generators, industrial turbines, humanitarian aid, locomotives, oil and gas equipment, space hardware. There was suddenly a market for an airplane capable of carrying what no other aircraft on Earth could lift. Engineers looked back toward the sleeping giant inside the Antonov hangar. Perhaps Mriya's greatest mission had never been carrying a space shuttle after all. Perhaps its true purpose was still waiting to be discovered. Yet before the aircraft could fly again, inspectors uncovered a series of technical and financial challenges that threatened to keep the dream grounded forever. Very few people realized just how close the world's largest airplane came to disappearing before its second life had even begun. The inspection teams moved carefully through the silent aircraft. Flashlights swept across the cargo bay, wings, hydraulic systems, and engine mounts. Dust had gathered over equipment that once represented the peak of Soviet engineering. Years of storage had preserved the aircraft remarkably well, but bringing it back into service would require far more than cleaning and routine maintenance. Every major system had to be inspected. Every hydraulic line had to be tested. Every electrical circuit had to prove it could still perform under enormous stress. The aircraft had survived the collapse of a superpower. Now it faced a different battle, the challenge of finding a place in a completely new world. Yet this wasn't the biggest obstacle. Money had replaced politics as the greatest enemy. Rebuilding and certifying the world's largest airplane demanded an enormous investment, and Ukraine, now an independent nation, faced severe economic difficulties throughout the 1990s. Many believed restoring the An-225 simply wasn't practical. Some aviation experts argued it would remain nothing more than an extraordinary museum piece, admired for what it had been but never again seen in the skies. But Antonov refused to let the dream disappear. Engineers believed the aircraft still possessed capabilities that no other transport airplane could match. Global industries were growing. Infrastructure projects demanded heavier equipment. Humanitarian organizations needed rapid transport after natural disasters. Commercial opportunities that had barely existed during the Cold War were now expanding every year. The world's largest airplane suddenly had a new purpose. After years of careful restoration, inspections, and modernization, Mriya returned to the sky in 2001. For the engineers who had watched it sit silently inside the hangar, the moment felt almost as emotional as its first flight. The 6 engines roared once again, and the giant lifted gracefully into the air as though it had never been grounded at all. But this time, the aircraft no longer served a superpower. It served the world. The missions that followed demonstrated just how unique the An-225 truly was. It transported enormous electrical generators to countries suffering energy shortages. It carried giant mining equipment that could not be dismantled. It delivered locomotives, wind turbine components, military vehicles, helicopters, and industrial machinery across continents. During humanitarian emergencies, it became one of the fastest ways to deliver oversized relief supplies wherever they were needed. Every landing attracted crowds. Airport observation decks filled with families, photographers, pilots, and aviation enthusiasts eager to witness the arrival of the largest aircraft ever built. Children pointed toward the sky as its massive wings slowly appeared over the horizon. Experienced airline captains often paused their own work just to watch Mriya taxi past. Even people with little interest in aviation immediately understood they were seeing something extraordinary. Then another remarkable achievement captured the world's attention. Throughout its operational career, the An-225 established well over 200 national and international records, including records for the heaviest single cargo ever transported by air and the greatest total payload carried by an aircraft. Many of those achievements remain unmatched because no other airplane has possessed the same combination of size, strength, and cargo capacity. Yet history almost forgot one fascinating detail. The Antonov An-225 was never intended to remain the only aircraft of its kind. Construction had begun on a second airframe during the Soviet era. Large sections of the fuselage, wings, and internal structure were completed before the collapse of the Soviet Union halted funding. For decades, the unfinished aircraft remained inside an assembly facility, occasionally sparking rumors that it might someday be completed. Engineers periodically examined the possibility, but the cost of finishing such a complex machine proved extraordinarily high. The second Mriya never reached the sky. The original remained unique. One airplane. One flying giant. One symbol of engineering ambition unlike anything before or since. Then came the event that no one wanted to imagine. In February 2022, Russia launched its full-scale invasion of Ukraine. As fighting spread across the country, Antonov Airport at Hostomel became one of the first strategic objectives. The airfield that had served as Mriya's home suddenly transformed into a battlefield. Heavy fighting erupted around the airport. Explosions echoed across the runways. Hangars shook under artillery fire and missile strikes. Inside one of those hangars rested the world's largest airplane. When the battle ended, heartbreaking images emerged. The forward section of the aircraft had been destroyed. Fire had consumed major structural components. The cockpit was gone. The center fuselage had suffered catastrophic damage. Around the world, millions reacted with disbelief. Aviation communities mourned as though they had lost a living legend. Pilots who had flown beside Mriya shared memories. Airport workers posted photographs from its countless visits. Engineers who had helped build and maintain the aircraft described the loss as deeply personal. Yet even amid the destruction, another story began to emerge. Antonov officials announced that rebuilding the aircraft remained a long-term goal. Engineers suggested that surviving components from the original aircraft, combined with sections of the unfinished second airframe, might one day make reconstruction possible. It would be an enormous undertaking, requiring international cooperation, advanced engineering, and billions of dollars. Whether that vision becomes reality remains uncertain. But the dream has always defied expectations. That is, after all, what its name has always meant. The legacy of the Antonov An-225 extends far beyond its incredible size. It proved that engineers could solve problems many considered impossible. It demonstrated that aviation was still capable of astonishing the world decades after the first jet age. It carried life-saving humanitarian cargo, supported industries across continents, and became an international symbol of innovation, resilience, and hope. Even in destruction, it continued to inspire millions. Today, every modern heavy-lift cargo aircraft is measured against the standard Mriya established. None have surpassed it. Museums preserve its story. Engineers study its design. Aviation enthusiasts continue to celebrate every photograph and every memory of the giant that once crossed the skies. The Cold War that inspired its creation has long since faded into history. The Soviet Union that ordered its construction no longer exists. The space shuttle it was built to carry flew only once. Yet the airplane outlived the mission that created it, and became something far greater than anyone could have predicted. It became a global icon. Some machines are remembered because they changed history. Others are remembered because they captured the imagination of an entire generation. The Antonov An-225 Mriya accomplished both. Its engines may have fallen silent, its hangar may have become a battlefield, and its airframe may have been broken, but the dream it represented has never truly disappeared. Somewhere inside every ambitious engineering project, every oversized cargo flight, and every attempt to achieve what once seemed impossible, the shadow of Mriya still flies across the sky.